Okay, so this video is basically showing how to extract a range of the soil plane using UCSF Chimera. And so first we're going to assume that Chimera is already downloaded. So you can basically go to the navigation bar and open it. And so if we open it, then first we can go to File and navigate to the file of our choice. So usually it will be an image slice. And so Chimera can take in two types of file formats. At least the ones that we're interested in are image slices such as these or MRC files. So in this case, we'll assume that we take as input the image slices. And so what you do is you select the first image slice in the folder, and then you click Shift, and then you left click to the last image slice, and then you click Open. And then it might take a little bit to load. Now, once it loads, when it initially loads, the resolution won't be very good because we're using a step size of 8. And so you can see that in the volume viewer, we can change the step size to view it at a better resolution. Let's change it to 1. So now we can see that we now see the more fine-grained architecture of the root. And basically, now I want to introduce some controls. So to rotate it, you use the left mouse button. So you drag around the left mouse button. And then to zoom in and zoom out, you click on the right mouse button, and then you drag up and down like this. And finally, to translate the model, you click on the middle mouse button, and then you click down on it and you drag it around. So this is the middle scroll of the mouse, and you click down on it and you drag it around. So now let's try to identify a range of planes where the soil plane could be. So now let's go back to the volume viewer. That can be done by going to Tools, Volume Data, and then Volume Viewer. And then now you can go to Features and Subregion Selection. And now what you can do is you click on Select Subregions, and you can see that says Select Subregions using the middle mouse button. So that's what we'll do. And now we can see that, we see this kind of green box. And now we want to define a plane, which is defined by this green box. So drag this. And basically to drag it, use the middle mouse button. Right, so now let's find a reasonable plane. And so it looks like in this case, we want to go a little bit up. So let's go to the top of this green bounding box, and let's click on the top side of this green bounding box and use the middle mouse button to basically drag this and drag it to the top. And similarly, let's go to this bottom side of this bounding box and also use the middle mouse button to click on this bottom region of the green bounding box, and let's shift it up. And so to rotate the whole model, you still use the left mouse button. So this is using the left mouse button. And to drag around this bounding box, use this middle mouse button. And these parameters can be changed in the volume viewer, using, it says select subregions using middle mouse button, but we can also change this to the left mouse button, middle, right, or control left, control middle, and control right. So in this case, yeah, let's continue finding a reasonable range for the soil plane. Now in this case, we see that it looks like the soil line is a little bit tilted with respect to the stem. So the stem, with respect to the z-axis, has a bit of tilt, and the soil line, which appears to be where most of the secondary branches start to cluster together and form, is a little bit tilted to the right. So you can see that the nodal roots to the right are a little bit higher compared to the nodal roots on the left. So to account for this, we also want to rotate our soil planes. And to do this, basically what you can do is you click on this button in the volume viewer in the subregion selection called Rotate Selection Box. And so now what we can do is now you can rotate the selection box using the left mouse button of the mouse. And so yeah, you can see that we can now rotate it to around this range, which looks somewhat more reasonable for the soil line. So we're able to, you can see that the soil line is now perpendicular to the stem. And so once we find something reasonable, we can uncheck the rotate selection box and observe the results from different angles. So we can see that for the most part, the soil line is captured in this case. Now that we have selected this region, we can click crop. And so this basically results in an additional volume being created. So an additional model. You can see that there's a top one right here. And so this is the original volume. And there's a bottom one right here, which is made up of the crop volume. And this crop volume is just this soil plane region that we rotated a bit that we can now play with independently. And so to visualize this separately, so we can see that currently both are visualized in gray, we can change the color of the soil planes to be a different color. So they're currently both in gray, and we can select the second model, which is the soil plane, and we can color it a different color. So let's say we want to color it red, and you can change it to anything you like using the color editor. And so let's say we change it to a pinkish color. And so now we can visualize both of them separately. The original volume is now in gray, and the soil plane is in pink, and we can continue rotating around the volume to see if this is a good choice. And let's say that we're okay with this result. Then we can see that the parameters of this soil plane can be found in the volume viewer. So at the top of the volume viewer, we have the origin index, which is basically saying where the origin of this soil plane volume is. So kind of the top left corner of the soil plane. And then it also has the rotation parameters. So you can see that here's the rotation axis, and here is the angle degree that you would rotate around that rotation axis. So how you can interpret this is, let's say, with respect to the original volume, we're basically rotating around the original volume by this amount, and then offsetting by this amount, the origin index. So now let's say we want to save these settings. So what we can do is, first that we want to save both maps as individual volume files. So we have the original image slices. So let's save the original image slices as an image volume. So let's say, yeah, we can just pick a file directory and say, right, so this is just saving the original volume, and it'll be saved as an MRC file. And similarly, so now let's select the soil line, the soil planes, and we can also save that as an individual volume. And this can be done by going to save map again. So save volume data again. And we can call it another name, so soilplane.mrc. And so now that we have both volumes saved, we can also basically save the session. And what this is basically doing is that it's saving both the orientations and the volume files into like a setting file. And so we can say this, so we can call the soil line settings, and it'll save this as a Python file. Right, so now that we've saved this into a settings file, we can now close this and basically reproduce this same view. And so now that we save the files and the orientations into a settings file, we can now open this back up in Chimera using the exact same settings using the setting file. So now we can go to Chimera again, and we see that we have the settings file saved. So we can open this, and we can see that we can reproduce the exact same result and view the rotation axis and origin index. And so that'll be it for now. Let me know if you have any questions.